For my community contribution, I will be exploring two packages, visNetwork and igraph. visNetwork is an R package that focuses on creating interactive network visualizations. It's quite ideal for presentations and making user-friendly visuals. On the other hand, igraph is used for in-depth network analysis. It allows us to calculate various graph metrics like centrality, shortest paths, clustering, and community detection. So the first step is loading the libraries. Next, we move on to the dataset. I've taken a Harry Potter dataset from GitHub and modified it a little. So here's a list of the Harry Potter characters. And in the second column, we see their houses. I have added this column. Next, we move on to the edges. So basically, we have the weight column that tells us the number of interactions two characters have had in the first book of the series. So for example, Albus Dumbledore and Harry Potter have had a total of 196 interactions in the first book. We then move on to creating the network. I've put a different color for each Hogwarts house, dark red for Gryffindor, green for Slytherin, blue for Ravenclaw, yellow for Hufflepuff, and for those characters that don't belong to a Hogwarts house, I've put gray. I then use the left join function to make sure that the nodes and edges match in both the datasets. I've then used visNetwork to create the network, as we can see over here. If I select a particular ID, if I select Hermione Granger, I can see all the nodes that that particular character is connected to. If I select Quirrell, I can see the nodes that Quirrell is connected to. And if I select the house like Gryffindor, I can see all those that belong to Gryffindor, all those that belong to Hufflepuff, all those that belong to Slytherin. So it's quite an interactive graph, and I can zoom in or zoom out, fit it to frame, and I can even move it towards the left or the right. I can even move the positions of the nodes like this. So visNetwork is highly interactive in nature. Next, we have degree. Degree is basically the number of edges that are connected to a particular node. Here is where igraph comes into the picture. It helps us to calculate the degree for the nodes. Harry Potter has the highest degree of 37 as expected, which means he's connected to 37 other nodes, followed by Ron and then Hagrid. So again, we have a look at the network. Here it's ranked by the degree rank. So if I select a degree rank of 6, I see the characters that have the 6th highest degree in the network. So it's a match between Draco Malfoy and Albus Dumbledore. And when I hover over it, I can see the character and the degree. Please note that only the outgoing edges in this network are highlighted. Next, we have weighted degree, which is the sum of the weights of all the edges connected to a particular node. So these nodes have some of the highest weighted degrees in this network, which tells us that these characters are highly influential. This is calculated with igraph and then plotted with visNetwork. Similar to degree centrality rank, we have weighted degree rank. So let's say we check the weighted degree rank 16. We have Fred Weasley, who has the 16th highest weighted degree in this network, which is 133. We can even perform community detection, which is quite interesting since we use Leuven clustering in igraph to find the nodes that are more densely connected to each other due to shared properties of frequent interactions. In this scenario, we have 5 communities in this network. The first one is majorly centered around Harry Potter. The second revolves around a group of Slytherin friends. The third consists of 3 of the Weasley brothers. The fourth is mainly the Muggles. And the fifth one is a couple of centers. Lastly, we have graph theory metrics like eccentricity, which is the maximum distance from a node to all other nodes in the graph. So if Ron has an eccentricity of 3, it means that he can traverse to any other node in the network within a distance of 3 or fewer edges. The maximum eccentricity is 4, while the minimum is 2, and the average is 3. The small difference between all of these tells us that the graph is uniformly connected with no extreme outliers, and all of this is calculated using igraph.